So I've been thinking about this for a while, and it turns out that data augmentation is a pretty useful technique. I'm 99% sure that most of you have used data augmentation before, probably on your training data set before you actually train your model. Here is a different way. If you give me a couple of minutes, I guarantee you, and I know guarantee is a strong word, I guarantee you I'm gonna show you a different way to use data augmentation that not only is going to surprise you, but it's gonna make your model better. Now, let me talk about data augmentation for just 1 second. Imagine you have a data set with 1,000 pictures. Data augmentation, as the name implies, is about getting each one of those pictures and generating small transformations here and there in order to create more data. There are many different ways to generate new samples starting from the original data set. For example, you can take every image and generate a new version by removing all of the colors, creating what we call a grayscale picture. Or maybe you could flip the image horizontally. You could also increase the exposure or maybe zoom in a little bit. So if you start with 1,000 images in your data set and you generate for each one of those images 4 different copies, 4 transformed copies of the original images, you will end up with a data set with 4,000 pictures. Now, data augmentation is very helpful. You can take a data set with not enough data and turn it into a data set that's good enough to train a decent model. Data augmentation will also help you to increase the variability of your data. Like if before all of your cat pictures were looking to the left, now you will also have cat pictures looking to the right. And this increase in variability will make your model more robust. So far, we've talked about data augmentation and the way 99% of the people use it 99% of the time. But there is something else. This idea that I'm gonna talk about today is called TestTime Augmentation. And as the name implies, is data augmentation that will be applied during test time, not training time. TestTime Augmentation is about giving a better chance to our model to make a good prediction. Here is how. Imagine you train a model to recognize cat pictures. Whenever you get an image and you have to run a prediction through your model, you have one opportunity to get that prediction correctly. Imagine that you created a cat model, very useful model. Given a picture of a cat, you'll be able to classify it depending on the type of cat it is. After you finish building this model and you deploy it in production, for every picture that comes in, you have one opportunity of getting the correct prediction. You take one image, send it to the model, get the result of the model, and that's it. Using TestTime Augmentation, we can increase our chance for our model to give us a correct prediction. Basically, instead of running one single image through our model, we're gonna give us a better chance by running data augmentation techniques and generating transformed versions of the original image. What's gonna happen is that instead of having one opportunity to get the correct prediction, we are going to increase the number of ways our model is gonna look at the same image, therefore augmenting the chance of the model seeing what's important and giving us back the correct answer. Let's assume you're building a multi-class classification model that uses a softmax output layer. That softmax will return a vector which largest value corresponds to the correct class. When using TestTime Augmentation, you're not gonna be giving the model the original image alone. Instead, you're gonna be passing to the model multiple copies of that image. For example, assuming you pass 4 different images to the model, you should expect the output to contain 4 different softmax vectors. Then the question becomes, how do we process all those 4 max vectors to obtain the final class corresponding to the picture? A popular way of doing that is to simply average out all those vectors to obtain the final resultant vector. You can then look at that final vector, find out the largest value, and that will correspond to the correct answer. Notice how we went from running a single picture through our model and using the output to determine the final answer to running the original picture plus multiple small variations of it in order to average out those results and using that to compute the final answer. Now, here is something important that you should keep in mind before you decide to use test time augmentation. Your success with this technique depends on how good your data augmentations are. Remember, you can easily destroy the ability for your model to make good predictions if you show it bad augmented samples. At the end of the day, you're averaging out the results of the original picture plus all of the augmented images that you passed through the model. So you want to make sure those transformations are good enough to improve the ability of your model to return good predictions, not decrease it. To get good results, my advice is that less is more when using test time augmentation. If you start slow and experiment frequently, I'm almost sure you are going to find transformations that will improve the result of your model. Now, of course, for machine learning, there are very few guarantees, so you might find out that for your particular problem, test time augmentation is just not a good fit. Okay, so that's it for today. I hope test time augmentation can help you studying right now, and I'll see you on my next video. See ya. It turns out that I think, with not enough data, but I think that I'm a better writer than YouTube creator, recorder, YouTuber, whatever this is called. So yeah, I need to keep practicing for sure.